All right, more stuff about circles. Now, I've already talked about, the point in the middle is called the center. Makes sense. You probably already knew that. Now, the way it works, a lot of times they'll name a circle after the name of the center. So this might be circle M. I mean, that's not that hard to understand. Just I figured I'd mention it. They use that all the time. Now, we also have some other lines we're going to talk about in the circle. If you connect any 2 points of the circle on the inside, this is called a chord. And a diameter is a special chord that goes right through the center and cuts the circle in half. So if you connect 2 parts of a circle, it's called a chord. If you have a line that goes through the circle and hits it on 2 parts, like goes all the way through, it doesn't just stop at the ends of the circle. If it goes all the way through, that's called a secant. Now, another thing we got to talk about, if you look just at part of a circle, like a curved line here with the same constant radius, a part of a circle, this is called an arc. You probably already knew that. So in a circle, we can measure arcs with like meters or inches or any amount of length like before. But also what we do in geometry a lot, you can also use degrees. And a whole circle in arcs is 360, just like before, and then a half circle, a semicircle, 180 degrees. Now we're gonna, at some point down the road, we're gonna use length like centimeters or inches to talk about arcs as well. But for now, we're just gonna use it in degrees. So this gives us some relationships we're gonna look at for the circles. First one is called the central angle. The vertex is the center of the circle. Makes sense? Central angle, vertex is the center. The way that this works, let's say this is called arc A, and we'll name this angle C for central angle. The measure of angle C is equal to arc length of A. And sometimes you'll see that for arc, a little curve over the top. So if you have a central angle, the angle here is equal to the number of degrees in the arc that it forms with the endpoints here. And another one similar to this, the name for this one isn't as evident. If we make an angle that the vertex is on a side of the circle, if you have a vertex on the circle, this is called an inscribed angle. So central angle, vertex is the center. Inscribed angle, the vertex is on the circle. The way this works, we'll use A for arc again. And this time I'll use I for this angle. So the measure of angle I is equal to half of the arc length like half the number of degrees in the arc. So central, equal. That's 30 degrees, that's 30 degrees. Inscribed, the angle is half of the arc. You could also think about it as the arc is double the angle. Either way, if this is 30, that's 60. I just realized I'm cutting off a little bit here. So if this is 100, the arc is 100, the angle is 50. And now there's just a little bit more. If we have two secants that meet at a point, they meet at a point outside of the circle and it forms an angle. The vertex is outside of the circle. We call this arc A. And the other arc that it cuts, B, and we'll use X for this. Measure of angle X is equal to the bigger arc, A minus B, all over 2. So the bigger one minus the smaller one, divided by 2, you get your angle. And one more. If we have two chords intersecting, now they intersect somewhere inside the circle. It might not be the center, so we're not necessarily talking about any central angles. The intersection could be anywhere in the circle. The way this works, let's take a look at this angle, which would also be, because they're vertical, would be right there. Either one of those. This time it doesn't matter which one's bigger or smaller. Either X here, because they're the same because of vertical angles, measure of angle X, instead of subtracting, you add. So for the more complicated problems today, if they intersect outside the circle, subtract. Bigger arc minus a smaller arc. If instead we have an angle formed inside the circle by two chords, again, not one of these two that we're talking about, then you add the arcs, divide by 2 to get the angle. All right. Now, some of these are real easy. It's just a matter of remembering, several days down the road here. So find the measure of the arc or central angle. Oh, this is the center. So the arc, 130, that means this angle, 130. That's it. Easy. It's just a matter of remembering it. And here, we're looking for that arc. It's equal 140. And on 3, just be careful of extra information here. This arc is equal to its central angle, so 135. And they can throw algebra at you with this. Here, central angle. So it's just the angle is equal to the arc that it makes. So we'll subtract 1, then divide by -67, and you'll get -2. 5, just be careful. Lines that appear to be diameters are actual diameters. We're looking for this arc, and we have a diameter. So the angle formed here is a straight line Straight lines, half of a circle, 180. So 180. This is a central angle, even though it's flat.
Testing 1, 2, 3. Testing 1, 2, 3.
We'll subtract 3. Then we'll divide by negative 59. And we get negative 3. So those were central angles because they're formed in the center. Now here we have our inscribed angles because it's formed on the circle, and it just ignore this other line. They're trying to confuse you. We still got this angle forming that arc. And like we said on the notes, the angle is half of the arc. So if we take 144 and divide it by 2, 72. So the angle is half the arc. Which means if I want the arc instead, if the angle's half, well, multiply it by 2 then. 45 times 2, 90. Some of these questions, like I said, are really just a matter of remembering. So here again, don't let this extra line here confuse you. We have an inscribed angle. So the angle is half of the arc, half of 84, 42. Now with these, if they throw some algebra at you, there's 2 ways you can do it. Like I said, the angle is half of the arc. So I could divide that 21x plus 5 by 2. You could do that. Or the other way around, instead of dividing that by 2, I could just double the 34. Since that's just a number, I'll do that instead. 34 times 2, 68. Double the angle, you'll get the arc. So minus 5, divide by 21. Now number 10. Oh, well, there's x's both places. So it doesn't really matter here. We can do it one of 2 ways. We can take half of that to get the angle. Or you can double the angle to get the arc. And that's a negative there. Kind of blended in with my equals. Either way, like here, this wouldn't be too bad.
Testing 1, 2, 3. Testing 1, 2, 3.
We can divide the 4 and the 18, or you could just cross multiply and end up multiplying by 2 over here, but you got these parentheses, and this one will just turn into that one either way. So it doesn't matter. Most people usually just like to distribute because they're more used to that. I lost my x. It's on the 18. There we go. We want to get our x's on one side, so I'm going to subtract 16 x. 18x minus 16x is 2x. We're going to add that 4. Divide by 2. 11. So for inscribed angles, you can either double the angle to get the arc, or you could half the arc to get the angle. Whichever way you find easier. Most people usually just double the angle. Doesn't matter though. Okay. Nope. Now we got 2 chords intersecting inside. We said when they cross inside the angle, you add the arcs, divide by 2. Now, when you type this in, if you type this in, be careful. If you just do that, it's only going to divide the 162 by 2. So you can either use parentheses, then divide by 2, or what some people just do, they hit enter after the first, then divide by 2. Either way. Oh, this one's weird. This time we're missing an arc, but just remember the formula. The angle equals, you add those. This is a question mark, so I'll use x. X plus, because we add, all over 2. So we can multiply both sides by 2. Then minus 74. 106. Oh, we're back to looking for the angle. So the angle, maybe I'll use, well, this is the same as u. So I'll use another u here. U equals, you add them up, divide by 2. Just remember, if you use your calculator, make sure you either hit enter or use parentheses. 103. Well, this is another one of those weird ones where we want the arc. So the angle is 81 degrees. That equals, you add the arcs and use x. To cancel out a divide by 2, I'll multiply by 2. Then we'll just minus the 75 there, 87. Same idea. I'll put an X there. The angle equals, you add the arcs. So multiply by 2, you get 240. Subtract 170, we get 70. Now, just be careful. It switches now to the subtraction formula. I'll use an X because I don't know that. The angle is equal to the bigger one minus the smaller one all over 2. Cancel out this 2 on the bottom. I'm cutting it off a little bit. Sorry about that. Multiply by 2. Add 60. There we go. This one, you got to be more careful with the order since it has to be the bigger minus the smaller. So on 17, bigger, the angle is equal to the bigger one minus the smaller one. Again, I'll just use x. All over 2. Multiply by 2. Now we'll minus the 145. Divide by -1. You get 65. So you subtract the bigger one minus the smaller one. I'll stick an X there. All over 2. Multiply by 2. Then we subtract 115, we get -45. X equals 45. Okay, now we're looking for the angle. Well, I'll just use R. So R equals the big one minus the smaller one, all over 2. Subtract those. You get 70, so 35. And again, the angle is equal to the bigger one minus the smaller one, all over 2. And, just like before, make sure you hit enter after you subtract or put the top in parentheses, or else you might get the wrong answer. 34.